In a single patent classification covering hybrid bonding, the microscopic copper-to-copper fusion that lets memory chips stack like floors in a skyscraper, YMTC, a Chinese company most Americans could not have named 5 years ago, holds 119 filings against Samsung's 83 and SK Hynix's 11. China's largest memory manufacturer outdocuments both Korean giants combined, 119 to 94. The bullish read is that YMTC has seized the intellectual frontier of the memory industry's most consequential fabrication technique. The skeptical read is that patent counts measure how busy your lawyers are, not how good your chips are. The architecture at the center of this contest is Xtacking, YMTC's named implementation of hybrid bonding, the specific method by which the company separates array and peripheral circuit dies, bonds them through copper-to-copper fusion, and stacks layer counts that would cause monolithic designs to collapse under their own thermal and structural stress. Xtacking is what the 119 patent filings describe, what the production wafers demonstrate, and what the entity list now constrains. 3 rounds will score it. Who owns the idea? Who built the thing? And who can actually ship it at scale? Because those turn out to be 3 different answers. The first claim on the table belongs to the bullish side, and it is arithmetically unambiguous. YMTC holds 119 hybrid bonding patents. Samsung holds 83. SK Hynix holds 11. Between them, 2 companies that have dominated global NAND production for over a decade sit at 94 combined. The raw number is not contested. It is reported across semiconductor industry analyses sourced to patent database searches, and the gap is not marginal. The bullish argument is that you do not file 119 patents in a niche fabrication category unless you have done the engineering, and a patent is a legal exhibit, not a press release. It can be subpoenaed, litigated, and licensed. YMTC is not claiming to understand hybrid bonding in the abstract. It is documented that understanding in 119 legally registered artifacts, each tied to a specific technical claim. The skeptical counterclaim arrives immediately, and it is not frivolous. Patent volume is a filing strategy, not a quality guarantee. A single foundational claim, one that covers the core mechanism by which copper pads fuse at the wafer-to-wafer interface under precise temperature and pressure, can functionally foreclose an entire design space. 10 peripheral patents around the edges of that mechanism do not collectively equal it. Samsung's 83 filings could, in principle, contain the one claim that makes YMTC's 119 workarounds necessary. SK Hynix's 11 could include the bonding alignment technique every competitor actually needs. Counting patents without reading them is like counting pages in 2 legal briefs and declaring the longer one the winner before the judge has read a word. The skeptical position is not that YMTC's patents are worthless. It is that more is a quantity, not a quality, and quality is what courts and licensing negotiations price. What can be assessed without a full claims analysis tips the scales. The category matters. Hybrid bonding for memory stacking is not a peripheral feature. It is the load-bearing fabrication method for high-layer count 3-dimensional NAND, and filing 119 patents in that category signals something different from filing 119 patents on packaging aesthetics. More to the point, Xtacking is specifically described in YMTC's own public technical disclosures as relying on hybrid bonding for its inter-die connectivity. The patent portfolio and the shipping product point at the same technical space. That correlation is something the skeptical argument about filing volume has to contend with. These are not defensive filings in an area YMTC does not touch. They are filings in the area its flagship architecture depends on, which means the breadth versus depth question, while legitimate, is not an argument that YMTC is papering irrelevant territory. Round 1 goes to China, narrowly, and with the caveat attached. The lead is real, the category is central, and the architecture connection is documented. But narrowly is load-bearing here. The skeptic's point about claim depth is not dismissed. It is deferred to the evidence round, where silicon either confirms the engineering or exposes a gap between documentation and capability. The second round asks a harder question. Does the patent portfolio show up in actual chips? The Xtacking layer count progression is the answer, and it is not ambiguous. YMTC moved from 128-layer NAND into 160-layer production, then into 232-layer, and reported 270-layer configurations. The method enabling that climb without catastrophic yield collapse is precisely hybrid bonding. By bonding the array and peripheral circuit dies separately and then fusing them, Xtacking reduces the thermal stress and height penalties that plague monolithic stacks at high layer counts. This is not a claim from a product roadmap. Independent teardown reports from semiconductor analysis firms, including work widely attributed to Tech Insights and covered in industry press, confirmed YMTC's Xtacking-based chips in consumer devices as early as its 128-layer generation. When an independent firm extracts the NAND from a shipping consumer product and identifies the bonding architecture through electron microscopy, that is not a company claim. That is an artifact. The architecture in the patent filings is the architecture in the silicon. The counterclaim in round 2 is legitimate and should be stated clearly. Layer count is a headline metric, not a comprehensive one. What matters commercially is yield, the percentage of dies on a wafer that pass quality thresholds, bit density normalized for die area, and cost per gigabit at volume. A company can demonstrate 270-layer NAND at a technical briefing and struggle to produce it profitably at scale. Samsung and SK Hynix have tuned their processes through multiple product generations, built supplier ecosystems around those processes, and accumulated the yield improvement data that only comes from shipping hundreds of millions of units across multiple quarters. As of mid-2025, no public independent yield data for YMTC's highest layer count Xtacking production has been published. The volume figures for YMTC's total output are substantially below Samsung and SK Hynix per industry analyst estimates. The skeptic is right that the yield curve at 270 layers could look like a mature process or an engineering sample, and right now no external source can answer that definitively. The teardown evidence is the most important exhibit in this round, and it resolves the core dispute without resolving the ceiling question. On the question of whether the patent portfolio corresponds to a real fabrication capability or whether it is theoretical, the silicon answers yes. YMTC's hybrid bonded Xtacking chips were not only designed, they were found in products in the market by independent analysts. The yield question is real and unresolved, but it is a question about how far YMTC can push the capability, not a denial that the capability exists at commercial scale. Those are different arguments. Round 2 goes to China, more decisively than round 1. The gap between patents filed and chips shipped is usually where bullish narratives collapse. Here, it does not. The architecture that generates the 119 filings is the architecture producing the wafers. The unresolved yield question matters enormously for round 3, but it does not disturb the foundation that round 2 establishes. Round 3 is where the skeptic lands the heaviest punch of the contest, and it connects cleanly. YMTC's placement on the United States Entity List, imposed by the Department of Commerce in late 2022 and documented public record, was framed at the time as a ceiling on its ambitions. The bullish argument in this round is structural and not without merit. Hybrid bonding lets you climb layer counts without the most aggressive lithographic node requirements, because the performance gains come from stacking rather than from shrinking the individual transistor. If access to leading-edge extreme ultraviolet lithography is constrained, and your architecture is specifically designed to substitute stacking for shrinking, then the hybrid bonding patent portfolio is not decorative. It is the primary workaround. The patent position becomes strategically more valuable precisely because the tooling constraints make the architectural path it covers more necessary. The skeptical counterclaim in this round is the most powerful argument of the 3. A patent on a process you cannot execute at scale is, in commercial terms, a trophy. Samsung and SK Hynix together ship an order of magnitude more in bits than YMTC. They do so with advanced tooling, mature processes, diversified customer bases, and unconstrained access to the global supply chain. The entity list does not merely restrict YMTC's access to one machine. It cascades through chemicals, advanced metrology equipment, servicing contracts for existing tools, and the engineering talent pipelines that depend on international collaboration. The fundamental limits here are not legal. They are material. Producing 270-layer NAND at the yield and cost structure that would allow YMTC to capture meaningful global market share requires equipment precision that domestic Chinese suppliers have not, as of mid-2025, demonstrably matched at leading-edge specifications. Industry analyst consensus, drawn from multiple independent assessments of the Chinese semiconductor equipment sector, consistently places domestic tooling capability several years behind international leading-edge specifications. That is not a closed gap. It is an open one, and the pace of closure is genuinely uncertain. The physical reality of this constraint earns the analogy that belongs here. Designing the world's most efficient engine and holding the patents on every component is not the same thing as being able to manufacture it when the machine tools needed to cut the tolerances are on a restricted list. YMTC holds the design. The machine tools are restricted. The question is not whether the design is real. It is whether the tools needed to execute the design at volume are accessible. And right now, the honest answer is not fully and not at leading-edge scale. On the metric that pays, bits sold per quarter at competitive cost, Samsung and SK Hynix are not close to losing. Their combined global NAND market share dwarfs YMTC's by a multiple that analyst estimates consistently put in the low single digits for YMTC's share. That is the output the market sees, the revenue that funds the next process generation, and the relationship with customers that determines whose roadmap gets designed into next year's products. Round 3 goes to the skeptics, and it goes convincingly. The patents are real. The silicon is real. The tooling wall is also real, and at this moment in the contest, it is the heaviest fact on the table. This is the decisive round, not because it erases what came before, but because it defines the terms under which the contest will actually be resolved. The prior 2 rounds established that YMTC's hybrid bonding leadership is not fictional. The patents correspond to real engineering, and the engineering produced real chips and real products. Round 3 does not erase that record. It reframes what the record means. A patent lead in a category where manufacturing scale is constrained by external restriction is a different kind of asset than a patent lead in a category where you can freely build the factories to exploit it. Before considering the verdict, the 3 strongest arguments against this ruling deserve honest weight. The first is that domestic equipment substitution could be faster than the consensus estimate. Chinese semiconductor equipment firms have shown accelerating capability development under sanction pressure. Multiple analysts who were confident about the substitution timeline 2 years ago have revised their estimates. If domestic tooling reaches the required precision specifications within 2 to 3 years, the round 3 verdict weakens substantially, and the dissent has evidentiary support even if it lacks a confirmed timeline. The second argument is that the Samsung and SK Hynix hybrid bonding response may be slower than assumed. Neither Korean manufacturer has shipped hybrid bonded NAND at the layer, counts YMTC reports in comparable volume. High-layer hybrid bonding is technically difficult for everyone, and if the incumbents face their own yield and process challenges scaling it, YMTC's architectural head start may compound rather than erode. No independent data on the incumbents' hybrid bonding yield curves at high-layer counts has been published, which means the round 3 advantage is scored on volume and tooling access, not on a confirmed head-to-head process comparison. The third argument concerns the patent portfolio itself as a licensing and litigation asset, independent of YMTC's manufacturing constraints. 119 hybrid bonding patents held by a sanctioned entity create a complicated situation for any firm that independently develops similar techniques. If Xtacking's architectural choices become the industry standard, which the layer count progression makes plausible, the portfolio holds leverage that the manufacturing constraint does not fully neutralize. That dimension is underanalyzed, real, and speculative, without more information on claim quality and cross-jurisdictional enforceability. Weighed together, these 3 dissents do not overturn the verdict. They define the conditions under which it could flip. The sanctions are the tiebreaker nobody scored at the start of the contest, and whether they remain decisive depends on industrial variables, not engineering ones. If domestic Chinese equipment development outpaces the consensus timeline and YMTC's highest layer count production reaches volume yield, round 3 flips, and the overall score changes character entirely. The margin is unstable in a specific direction, and that instability is the most honest thing the analyst can say. The ruling: on paper, China wins. YMTC holds the larger hybrid bonding patent position. The architecture is validated in silicon by independent teardown analysis, and the layer count progression from 128 layers through the reported 270-layer configuration is among the most aggressive in the industry for its tier. On the factory floor, the incumbents still win. Samsung and SK Hynix ship more NAND by a significant multiple at more mature process nodes, with unconstrained access to the global tooling supply chain. The score is 2 rounds to 1 in YMTC's favor, and the entity list is what prevented a sweep. The restriction that was supposed to answer the question instead changed it. Before the entity list, the contest was, can YMTC engineer its way to the intellectual property frontier? That question now has a documented answer, and the answer is yes. After the entity list, the contest became, can YMTC industrialize its way past the equipment ceiling? That question is still live, and nothing in the current public record resolves it. Xtacking is the object that carries both truths simultaneously. It is a genuine architectural achievement with a patent record and a teardown confirmation to match, running on a production line that the incumbent supply chains can reach and YMTCs currently cannot fully replicate at leading-edge scale. The company that owns the idea and the company that ships the product are the same company. They are just separated by a list of restricted equipment, and how long that separation holds is the only question that remains. Tell me which round you would flip, and if you flip round 3, tell me your timeline for domestic Chinese tooling reaching leading-edge hybrid bonding specifications, because that is the number the entire verdict turns on. If this kind of round-by-round adjudication is the format you want for the next contested claim out of the semiconductor industry, subscribe and turn on notifications. There are more contests on the docket.